So here we are again, section 4.3, linear functions, slope, and equation of lines. So this is the second part, and what we're going to do is to formally define what a linear function is, and then we will have some small properties of, I mean, some few properties of linear functions, and then the rest of the meeting will be devoted to answering the questions or problems I have prepared for this discussion. Okay? So, a linear function in the variable x, this is a function of the form f of x equals mx plus b, where m and b are real numbers. Okay? Now, if we choose a particular value for x, then we will have some real number m times that particular value of x plus b. And we say that it will be the image of the function f at x. So we may assign that image as y. Okay? Meaning, we can rewrite this as y equals mx plus b. Okay? And looking at this equation, notice that this is just the slope-intercept form of a line. Okay? Which means that the graph of a linear function is just a line with slope m and y-intercept b if the linear function is written this way. Okay? And the domain of this linear function is the set of all real numbers, because if you choose any real number x, you multiply it by some real number and add another real number, then you'll just get another real number. So whatever real number you choose, the value y will be defined. Okay? Now, here are some properties. Linear functions have constant average rate of change. Okay, so we've seen that if you have the line y equals mx plus b, we said that the slope is actually the average rate of change, and it is constant for lines. The slope does not change. If you are given a line, whatever 2 points you use, you calculate the slope, it remains as is, or it remains constant. Okay? So that is, the average rate of change of f of x equals mx plus b is just this m. And it can be calculated as the change of y over the change of x. And again, the y here, it's just your y equals f of x. Okay? Now, let f of x be equal to mx plus b. Then f is increasing if m is greater than 0. It is decreasing if m is less than 0. And it is constant if m is equal to 0. So remember the graph of a linear function, okay, for different values of m. So for m positive, the graph will be slanting from left to right, slanting upwards from left to right, and it is increasing. Okay? Meaning, as you increase your x here, the value of y will also increase. Okay? So if this is your Cartesian plane, this is your x, this is your y. So as you increase your x, the value of y also increases. So that is the case when m is positive. And then when m is negative, so this is your Cartesian plane, x and y. When m is negative, your graph will be something like this. Okay, this is decreasing. So slanting downwards from left to right. So as you increase the value of x, the value of y decreases. Okay? And of course, if your m is equal to 0, then you just have f of x equals b, or y equals b. Okay? So the graph is just a horizontal line, or the function is constant. Okay? So this is your x, this is your y. Constant, because whatever change you do in your x, the value of y remains the same. Okay? So let's work on some examples here. Find the linear function f if it satisfies f of -1 equals 3 and f of 3 equals -6. So to do this, we have the following. We know that f of x, since this is a linear function, according to this, your f of x must be of the form mx plus b. And then we use the informations that we have in here. Okay, so it is said that if we evaluate f at -1, the value of the function will be 3. Okay, so you have that. F of -1 equals 3. So I just wrote it this way. Because on the other side of f of 1, on the right-hand side, okay, we use this equation here, or this formula here, or this form here. We substitute -1 here at this x here. So you will have m times -1 plus b, or simply you have -m plus b. Okay? Similarly, for this information, f of 3 equals -6. So you have f of 3, this is equal to -6. If we substitute x equals 3 in this equation, or in this formula, we will have m times 3 plus b. Okay? Now, what we see here is, or are two equations with two unknowns, m and b. Okay? So we can create a linear system of two equations in two unknowns. So we have the following linear system. -m plus b. This is equal to 3. And then you have your 3m plus b. This is equal to -6. And our job now is to determine the value of m and b. Once we know the value of m and b, we now have the actual linear function. So all we need to do now is to solve this linear system. And we had several ways to solve linear systems. Okay? And for this guy here, for this linear system, what we're going to do is to use elimination method. So let us label this as equation 1 and this is equation 2. What we can do is to eliminate b. Okay? So to eliminate b, we can subtract the equation, second equation minus the first equation. Okay? So 2 minus 1. So we are going up. So in here you have 3m minus -m. That will give us 4m. And then you have here b minus b. That's just 0. And then here you have -6 minus 3. That's equal to -9. Okay? And therefore, we can solve for m. Okay? We can solve for m. M will be -9 over 4. Okay? Now, to solve for b here, we just substitute m, the value of m that we have obtained, okay, in any of the equation here. So what we can do is to substitute maybe substitute m equals negative 9 over 4 to equation 1. So in equation 1, we now have negative of negative 9 over 4 plus b. This is equal to 3. Okay? So if we put this number here to the other side of the equation, we'll just get b equals 3 minus 9 over 4. And if we simplify this, what will we get? So 3 times 4, that's 12. 12 minus 9, that's 3. So we will get 3/4. Okay? Question so far? And therefore, we now have the function f of x. So let's just write it here. So f of x now, this is equal to mx plus b. M, it's negative 9 over 4. So you have negative 9/4 x, and then b is 3/4. So you have plus 3/4. So this is the desired function. Okay? For the next problem, find the value g of negative 3 if the linear function g satisfies g of negative 4 equals 2 and g of 5 equals 12. Okay? So for this problem, we have two goals. First goal is to find the function g. Okay? Once we know the function g, we can now calculate g of negative 3. Okay? Now, according to this, g is also a linear function. So just like before, your function g of x is of the form mx plus b. Hence, the solution will be very much similar to what we did in the previous example. So in here, we have g of negative 4. And according to this, it's equal to 2. But on the other side, we replace x with negative 4. So you have m times negative 4 plus b. From this, we have g of 5, and that's equal to 12. On the other side, we have m times 5 plus b. Or let us rewrite this again as negative 4m plus b. This is equal to 2. And then you have 5m plus b. This is equal to 12. So again, let's write this as equation 1 and equation 2. And just like before, we will solve this by elimination. Okay? The reason is, look at this. You have b and b here. So the variable b here, at least in this linear system, can be eliminated easily, just like in the previous example. Okay? But you can use other method. You can use substitution method if you want. But anyway, let's eliminate this b here. We again subtract. This time, let's just subtract equation 1 minus equation 2. So what we will get, so equation 1 minus equation 2, we will have minus 4m minus 5m. We get negative 9m. Then here you have b minus b, that's just 0 again. And then on the other side, you have 2 minus 12, that's negative 10. And therefore, our m will just be 10 over 9. And then we substitute this m to any of the equation here. Okay, let's just substitute the value of m equals 10 over 9 in equation 1. So we will have negative 4 times 10 over 9, okay, plus b, this is equal to 2. But this guy here, it's just negative 40 over 9 plus b equals 2, or b equals 2 plus 40 over 9. Then you combine this into a single fraction, you should get 58 over 9. So 2 times 9, that's 18. Then 18 plus 40, that's 58. And you have this over 9. Okay? And therefore, our g of x will be m, it's 10 over 9. So you have 10 over 9 x plus b, it's 58 over 9. 58 over 9. Now, we are interested in the value of g of negative 3. So we just substitute x equals negative 3. And therefore, we will have 10 over 9 times negative 3 plus 58 over 9. This guy here, it's negative 30 over 9 plus 58 over 9. And this is just 28 over 9. So this is the value of g of negative 3 if the function g satisfies this equations. Okay? Any questions? Okay. For our next example, let f of x be equal to 3x minus 2 and g of x be equal to 5 minus 3x. Then let us do these 4 problems here. So for the first problem, we want to solve for x such that f of x is equal to 0. But this means you just need to equate 3x minus 2 equals 0, or you have 3x equals 2, or your x equals 2 over 3. So we easily get this value x. Okay? For the second problem, we have f of x equals g of x. So we want to solve for x such that f of x equals g of x. Now let us use the representations for your f and g. So on the left-hand side, we have 3x minus 2. On the right-hand side, we have 5 minus 3x. Then we just isolate x on one side of the equation and the constants on the other side of the equation. So we can move this 3x from the right-hand side to the left-hand side, and then this 2 from the left-hand side to the right-hand side. So we will have 3x plus 3x. This is equal to 5 plus 2, or that we have 6x equals 7. And therefore, x equals 6, it's 7 over 6. Okay? For number 3, this time we want to solve f of x less than or equal to g of x. So we have f of x less than or equal to g of x. The solution will be very much similar to this, but instead of equality, we have the inequality, less than or equal. Now, take note, on the left side, you have f of x. So you have on the left side 3x minus 2, and then less than or equal, and then you have 5 minus 3x. So we move this minus 3x from the right side to the left side. We move this minus 2 from the left side to the right side. And we will get 3x plus 3x. Take note that the inequality will be unchanged, okay, or will not change. And then you now have on the right-hand side 5 plus 2. So here we have 6x less than or equal to 7. And if we divide x by 6, or if we divide everything here by 6, since 6 is positive, the inequality will not change. So we'll just have x less than or equal to 7 over 6. Okay? For the number 4, okay, we want to sketch the graphs of y equals f of x and y equals g of x. Then we will label the point that represents the solution to the equation f of x equals g of x. So we have the value of x. We will need the value of y later. So all we need to do is to substitute this x with any of f or g. Okay? But first, let us sketch the graph of each function. So let us say this is your Cartesian plane. Okay? This is your Cartesian plane here. So this is your x, this is your y. Okay? I think I need to adjust this. So let me adjust this. So here you have your y in here. And then your x, let's just move it downwards, a little bit downwards. So this is your x. Okay? So label this as 1, 2, 3, 4, 5, and this is your 1, 2, 3, 4. I need higher here. And maybe this is our 5. So I hope that's balanced. But anyway, assume that the scaling is just fine, although it's not. Okay. So for this guy here, anyway, let me fix this. So we will have 1 in here, 2, 3, 4, 5. Now to sketch, okay, we'll need 2 points. And remember, we can use 2 intercepts, the x-intercept and the y-intercept of the functions, okay, to obtain pair of points. So for example, for the function y or function f, okay, y equals 3x minus 2. If x is equal to 0, okay, if x is equal to 0, then the value of y, So if x is equal to 0, the value of y will be just -2. If y equals 0, then you have 3x minus 2 equals 0. But we solved this. We solved that x must be equal to 2/3. Okay? So we have the points 0, -2, 2/3, 0. This is for the function y equals f of x. So 0, 2. So we have this point here. And then 2/3, 0. 2/3, so it's somewhere here. Okay? And therefore, the graph will be something like this guy here. Okay? So this is your y equals f of x.
Sir,
Yes, question?
why did you put the y equals -2 to +2 and not -2?
You are right. You are right. My apologies. It should be y equals -2, so it must be somewhere here below. Correct. So
Okay.
let me change that. So erase, 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 erase. Okay. So we have this guy here. So -1 and then, oops, -1, -2. So one of the points must be in here. Then the other point is still in here. Okay, that's say 2/3. So the line will be something like this. So this is your y equals f of x. Thank you for that correction. Okay. And then for the other guy, now we have y equals g of x. So y equals 5 minus 3x. And similar solution, if x equals 0, then y equals 5. Now, if y equals 0, then we have 5 minus 3x equals 0, or we have 3x equals 5, or x equals 5 over 3. Okay? So, we have this guy here. It's the 0, 5. Okay? And then we have 5/3, 0. 5/3, it's 1 and 2/3. So it's somewhere here. Okay? It's somewhere here. So if you get now the graph, it's something like this. Okay? So assume that it's a straight line. So this is the graph of your y equals g of x. Okay? Now, we look at this. Label the point that represents the solution to the equation f of x equals g of x. So graphically, the solution to this is the point of intersection of the two lines. So the point of intersection is somewhere here. And according to our computation, okay, according to our computation here, f of x equals g of x, so you have x equals 7 over 6. Okay? So it looks like this is 7 over 6. Okay, it's just somewhat your x equals 7 over 6. It's after 1. Oh, it doesn't look like x equals 7 over 6. But anyway, the scaling, my scaling is not correct. But at least it's the x coordinate, it's greater than 1. Okay? So if I have a better scaling, or I have drawn the grids here or the ticks here more accurately, then the point will be more accurate also. So anyway, this is 7/6. And the y coordinates, let us solve for the y coordinates. So you can use x equals 7/6 on either f of x or g of x. Let's just use f of x. Okay. So y, or f of 7/6, this is 3 times 7/6 minus 2. But this is equal to 7/2 minus 2. And this is what? 3/2. Okay? Or 1.5. So it must be somewhere up. Okay? But anyway, at least it's above the unit 1 here. 3/2 it's somewhere here. But anyway, again, scaling is not accurate. Let's just label that this point here, okay, is the point 7/6, 3/2. Okay. Question. Okay. So normally the problem is not like this. It's not that you are given the equation of the line, or it's not that the function is not given. Okay. Normally the problem is written in words. Okay. So they are word problems. And our goal when we have word problems is to construct a model to solve the word problem. So in this case, what we're going to do is to build linear models based on the information that we have in the problem. Okay? For example, it costs $350 to print 100 copies of a manual and $800 to print 250 copies of the same manual. So assume that the relation between the cost y of printing x copies is linear. Okay? So in here, so we are assuming, so let's just have y here. You have your y equals mx plus b, because we are assuming that the relation between y and x are linear, or is linear. So it must be of this form. So here, for letter A, we want to express the cost in a linear equation with number of copies. In short, we need to find the value of m and b. And then for letter B, since we now have the model, we want to find how much it would cost to print 650 copies. Okay, so let's start for letter A. So let y be the cost of printing x copies of the manual. Okay, then we have the following. Since it's linear, your y must be some mx plus b. Using this information here, now the cost is $350 if we print 100 copies. So m times 100 plus b. And also, it costs $800 to print 250 copies. So we have M times 250 plus B. So now we solve this system. We can label this as equation 1 and equation 2 here. So we want to solve for the system, solving for the system. So we can subtract. Let's subtract equation 2 minus equation 1. So if we do that, we have 800 minus 350. That's 450. Then here you have 250m minus 100m. That's 150m. And then b minus b, that's just 0. So from this equation now, we will have m equals 450 over 150, and this is equal to 3. Okay? Now, we solve for the value of b here. We change m equals 3 to any of the equation here, 1 or 2. Let's just use 1. So now, in equation 1, we have b, or we have 100 times 3 plus b equals 350. Or we have here 300 plus b equals 350, or that your b equals 350 minus 300, and this is equal to 50. Okay? So the cost y, okay, the cost y is given by 3x, okay, 3x plus 50. Okay? So this is the answer for letter A. For letter B, since we now have the model, okay, all we need to do is to substitute x equals 650. Okay? So if we need to print 650 copies, then we have y equals 3 times 650 plus 50. This is what? 1950 plus 50. And this is equal to 200 or 2000. Okay? Therefore, it costs $2,000 to print 650 copies of the manual. Okay? Question? Okay? Now, for our next problem, let me borrow some concepts from economics. So particularly, will have supply and demand. Okay? Now, the quantity supplied of a good is the amount of a product that a company is willing to make available for sale at a given price. Okay? The quantity demanded of a good is the amount of a product that consumers are willing to purchase at a given price. So if you look at this, the quantity supplied is usually in the perspective of the companies or of the manufacturers or of the producers. Okay? While the demand, okay, the demand is most of the time from the perspective of the consumers. Now, both supply and demand are related to the price of the product or the goods. Okay? And therefore, if they are both related to the price, okay, then the quantity supplied and the quantity demanded can be also related to each other. Okay? Now, from economics, according to what they call the law of supply, okay, as the price of the product or the goods increases, the quantity supply also increases. Okay? Why is that? Take note, the quantity supplied is from the perspective of the company. So if the product has increasing price, most of the time the company will take advantage of that. Okay? Because they will gain some profit if they produce a big number of supply and they were able to sell those goods at some higher price, then they have more profit. Okay? On the other hand, the law of demand states that if the price increases, okay, if the price increases, then the quantity demand decreases. Okay? So again, take note, the quantity demand or the demand is from the perspective of the consumers. Of course, if the price is high as a consumer, you are not tempted to buy it because you don't want to spend much. Okay? So conversely, as the price decreases, okay, as the price decreases, the demand will increase. Correct? Okay? So, if we look at this graphically, okay, say this is your price P, okay, and this is the quantity, okay, quantity. For the supply, for the supply, okay, it says as your price increase, as the price increases, the company will produce more supply, so they will gain more profit. Okay? So you will have something like this. And again, take note, this is on the perspective of the company. You increase the price, if the price is increasing, you increase the quantity to gain more profit. Okay? So this is for the supply. On the other hand, from the perspective of the consumers, okay, if the price is decreasing, okay, or if the price is increasing, the demand will be lesser. Okay? So from lower price, okay, from lower price, starting from here, okay, you start from here. The reason is if you have lower price, you have higher number or you have higher demand. But if you increase your price, okay, if you increase the price, the demand will become lower. Okay? So this is the demand. Of course, at some point, at a certain price, the supply and the demand will agree. Okay? And as you can see on this graph, it's probably at this particular point. Okay? So there will be some price in here, some price, let's just label it as peanut. And of course, in here, it's just some quantity. Okay? So meaning, at a certain price, peanut, the supply that the company will be making is only at this quantity. Okay? Let me put it as Q naught. And because the price is peanut, okay, all the consumers will buy. And therefore, the demand will be also at this point. We call this the equilibrium point. And the price here, it's called the equilibrium price. Okay? So, the equilibrium price of a product is defined as the price at which quantity supplied equals quantity demanded. Okay? Now, let us use these concepts, okay, to our next problem here. Suppose that the quantity supplied S and the quantity demanded D of hot dogs at an event, okay, are given by the following functions. S of P equals negative 2,000 plus 3,000 P. D of P equals 10,000 minus 1,000 P, where P is the price of the hot dog. Okay? So notice, for the supply function, the coefficient of P is positive. Okay? So as you increase the value of P, the supply function will also increase. Okay? Because the company will take advantage of higher price, okay, to get more profit. On the other hand, look at this, the demand function. P, the coefficient of P here, it's negative. So if you higher, if the price is higher, there will be higher negative here. Therefore, you will have 10,000 minus higher negative, the demand becomes smaller. Because again, if you increase the price, tendency of the consumers is not to buy because the price is high. Okay? So these two equations here are consistent with the at least law of supply and law of demand. So let us solve the problems here. Find the equilibrium price for hot dogs at the event. So for letter A, equilibrium price, we need the P such that S of P equals D of P. So we want to find P so that S of P equals D of P. S of P, it's 2,000 or negative 2,000 plus 3,000 P. This is equal to, the D of P, it's 10,000 minus 1,000 P. So we solve this. We move this negative 1,000 P to this side. We move this negative 2,000 here to the right side. So we will have 1,000 P plus 3,000 P. This is equal to 10,000 plus 2,000. So we will have 4,000 P equals 12,000. And therefore, P equals 12,000 divided by 4,000. And that's equal to 3. So the equilibrium price must be, let's say this is in dollars. So the equilibrium price is $3. Okay? For letter B, what is the equilibrium quantity? So it's just the number of hot dogs available at P equals $3. Okay? The quantity equilibrium quantity is, we have S of 3, or you can use D of 3, because anyway, they are equal at P equals 3. Let's just use S of 3. This is equal to minus 2,000 plus 3,000 times 3. But this is equal to what? Minus 2,000 plus 9,000. And this is equal to 7,000. Okay? Meaning, if the seller, okay, if the seller intends to sell the hot dogs at $3, okay, the seller just needs to produce 7,000 hot dogs and everything will be sold. Okay? For letter C, determine the price for which the quantity demanded is less than quantities supplied. So our goal is to find P so that the quantity demanded, so your D of P is less than quantity supplied, which is S of P. Okay? So what do we expect? Quantity demanded will be less than the quantity supplied. Okay? Which means the demand will be less, which means you need a higher price. Okay? You need a higher price. So if you solve this, that is our expectation. Our price must be greater than 3. That's our expectation. And let us see if it is consistent. Okay? If our guess is actually the solution to, or to the price that we need to, or that the price that we will solve. Okay? So we expect price will be greater than 3. Let's see. D of P, that's 10,000 minus 1,000 P. This must be less than S of P, which is minus 2,000 plus 3,000 P. But here, what we're going to do is to move this minus 1,000 P to the right side and move this minus 2,000 to the left side. So the inequality will not change. The inequality direction will not change. But that's just precisely this step here. Okay? So we will have 10,000 plus 2,000. This is less than 3,000 P plus 1,000 P. And eventually, if you continue to solve this, you will get P greater than 3. Okay? Or this guy here, P greater than 3, which is the one that we expect. Lower demand because the price is higher than the equilibrium price. Okay. Question. Now let's move to another problem. Another type here, a truck rental company rents a truck for 1 day by charging $31.95 plus $0.89 per mile. Okay? Write a linear model that relates the cost C in dollars of renting the truck to the number of X of miles driven. And then, what is the cost of renting the truck if the truck is driven 110 miles or if the truck is driven 230 miles? Okay? So for letter A, we already have the cost here, or I mean the representation for the cost, which is C. So if X is the number of miles driven, okay, the number of miles driven, the cost is given by, we have C of X. This is equal to, so we have a fixed rate here, 31.95 plus 89 cents per mile. So X is the number of miles. So we have here plus 0.89 X. And that's it. That's our letter A. For letter B, what is the cost of renting the truck if the truck is driven 110 miles? So if X equals 110, then we just have C of 110. This is equal to 31.95 plus 0.89 times 110. And please calculate this. Let's see. We have 110 times 0.89 plus 31.95. I got here 129.85. Okay? So the driver has to pay, has to pay $129.85 for driving 110 miles. 110 miles. And then for the other one, if X equals 230 miles, then we just solve C of 230. And again, this is just 31.95 times 0.89. 31.95 plus 0.89 times 230. So if we compute this, we have 236.65. So please check my calculation. So this means the driver or the renter or whatever, so the driver has to pay $236.65 for driving 230 miles. Okay? Questions? Next problem here. The population Y of a small city has been growing linearly since 1985 as follows. Y equals 2,755x plus 12,000, where x is years since 1985. So what is the population in 1985? What was the population in 2010? And the third problem is, when will the population reach 100,000? So in here, X is years since 1985. Okay? So in 1985, the value of X will be 0. Okay? So the population will be, the population was Y equals 2755 times 0, that's just 0, plus 12,000. So the population was 12,000. Letter B. In 2010, okay, X is equal to 2010 minus 1985. Correct? Because X is years since 1985. So the starting it's 1985, and that's why here X equals 0. But in 2010, we have to subtract 2010 minus 1985. And this is equal to 25. Okay? So the population was Y equals 2755 times X, which is 25, plus 12,000. And calculate this. We have 80,875. Okay? Questions so far? And finally, for letter C, when will the population reach 100,000? So for letter C, we want to find X so that we have 1,000 or 100,000 equals 2755x plus 12,000. Okay? Solving for x, we have So you have 2755x equals, we move this 12,000 to this side of the equation, and then we interchange the equation or the quantities. We have 100,000 minus 12,000. But 100,000 minus 12,000, that's 88,000. Which gives us x equals 88,000 divided by 2,755. So this means, what is x? It's roughly 31.94. And let us approximate this to 32 years. Okay? So in 1985 plus 32 years, okay? So in 1985 plus 32 years, and this is 2017. So in 2017, the population would be approximately equal to 100,000. Would be approximately 100,000. Okay? Questions? Okay. So this will be my last problem for this session. During your off hours, if you have time and not yet tired, I want you to work on the other problems that is in this or that are in this presentation. So you still have 1, 2, 3, 4. Okay, 4 more problems in here. The problems are similar to what we have already done. And then furthermore, you can work on as many problems as you can, okay, on pages 99 to 102 of the 016 module. Okay, so thank you.